Hey everyone, welcome to Motor Psychology. My name's Jonathan. If you're a new viewer, welcome. If you're a returning viewer, welcome back. Thank you so much for your support. It is greatly appreciated. So in today's video, I'm going to be working on this 1987 first generation Honda CRX. It's one of three that I own, and this one is going through the major restoration. Now, I've been doing lots of work on it, lots of welding, and doing some repair there. So in this video, I'm going to show you how a 3D printer can be very useful and very beneficial for fabricating hard to find or impossible parts to find for these type of vehicles. So in this video, I'm going to do something simple. I'm going to design and print and install a choke retaining nut. Now this nut is impossible to find, and the only reason that I know kind of like what it looks like is from my other Honda CRX that has a new, relatively new one that I bought several years ago to replace the one that cracked. So I'm going to be taking you through the design process that I use and the printing process, and then the final fit on this old CRX. So stick around, enjoy the video, and let's get started. So this car is the same as the one that I highlighted in my other video. Pretty much identical, except it is blue inside. And right now I'm using it to store some tires for my Corvette. And it's dusty in here, but we're going to get this thing finished this year, or pretty much finished this year. I have already taken the carpets out and been working on a lot of welding along the sides, which I'll show in another video, but you can see down here some of the welding work that was done along the way as well. So that's going to get ground down and then fixed at some point. So let me get set up for what I'm working on, and I'll be right back. So what I plan on working on is designing a retaining nut, which is going to be out of plastic, for the choke mechanism, which is right here. So let me take off the choke knob here, which I've already unscrewed so it comes off easy, and I'll put that back later on. A lot of you guys aren't familiar with chokes in the first place, but in order to start this car, if you see my other video, you see me pulling on the choke to get it started. So what was common with these cars, since they had a plastic retaining nut on there, they cracked over time and they eventually fell off. So you get to a situation where you can certainly pull the choke out fine, but you can't push it in because it goes into the dash. So what I want to do is fabricate a retaining nut that is going to go on this piece here. Let me get a close up here. So on here, I'm going to be fabricating the retaining nut on here, and I'll show you how I'm going to do some of the measurements for that as well. So one of the tools that is going to help me determine the thread size, anyway, that I'm going to be looking for are these little tools here. So this one is a metric, and I'm pretty sure with the Honda we're dealing with metric. So you can try these and line them up with the threads that are on the part of that choke that is sticking out, and try and determine what the threads are. So you've got a 6.0 or a 0.9, you've got a 1.0, and they just keep on getting bigger and bigger. You got the same on this side, a little bit smaller as well, and you've got your imperial or SAE here as well. And these type of things usually come in a typical tool and die set. So that's one of the tools that I'm going to be using. The other tool that I'm going to be using is an electronic caliper set, and it looks like this. So this does both metric and SAE, and it will just allow me to measure the size of that nut, for lack of a better word, that is part of the choke mechanism that's sticking out. And this is pretty simple to operate. You just turn that to get your outside dimensions, and you can see the reading on there. And if you're looking at inside, you've got the other part there as well. And once you find it, you just tighten that up. It won't move, but you get your measurements, which are useful, so you can add that into your CAD software. So I'm going to go out and take the measurements right now. So I'm going to be measuring the thread depth here and width on that, and then I'm also going to be measuring the diameter of this part as well. So I'll arrange the camera and then we'll go in and check thread. So as I go in and do that, I already can see visually that these guys are probably too small. This one at the end might fit. That one's pretty close. It's a 27, but not quite there. I'm going to check some of these other ones here. This one here is going to be a 1.0, so I'm going to check that one. So you can see that. And we'll just line it up on the top. And to me, right now, that looks like a good alignment. So that looks like what I'm interested in. That's a 1.0, and now I'll do the outside measurements. Okay, working through this, I'm going to be doing the outside measurement of that, and let's see how it goes. So the outside measurement is 13.59. So that is 13 millimeters, 0.59. So if you're doing it in standard, you just change the settings. But this is a metric car, so I'm going to be doing it in metric. So 13.59 millimeters. And that's a good reference because we're going to need that in the CAD software. So let's go inside and start designing the piece. Looking at this and just starting off on the CAD software, to get the basic shape, I'm going to pull a cylinder from the menu that's on the right, so an open cylinder, and then I'm going to adjust some of the size dimensions, which you can just input into these specific areas. So I'm shortening this one down to 4 millimeters, and that makes at least the outside diameter what I'm looking for. Now as I'm moving ahead to look at the inside diameter, I know that it is 13.59 millimeters. So looking at the grid or the graph paper that's on there, it's broken down. The larger squares are 1 centimeter, so the tiny little ones inside are 1 millimeter. So as I'm looking down on this, I'm actually counting out 13 and a half, more or less. So I'm really eyeballing it. I don't really have a better way to do the inside measurement, so I'm eyeballing it and making some adjustments for it. So once I'm happy with that, I'm bringing in a square or a cube object, and then I'm adjusting the size of that, and I really want to just make it about, I don't know, half a centimeter, or 5 millimeters by 5 millimeters, and take it from there. So I'm going to be using this object to cut into that cylinder to make various types of spaces that will later become the outside grip areas of this, and you're going to see that shortly on what I do here. So this is just me trying to figure out what would be a good shape that I can use to move into the outside wall of this cylinder. And I'm almost there. There we go. So it's going to be about 5 or 6 centimeters or 5 or 6 millimeters tall, and you can just move it in and encroach it right in there. And once you have the right depth, then you can just Control C and Control V to copy and paste a new one. And these are totally flexible to rotate in the right direction that you want and then park it in the cylinder. So I'm going to keep on doing this process until I have enough of these around the outside circumference of this cylinder that it's going to give me the shape that I'm looking for. So I'll be doing that, and I'm going to advance the video at about 10 times speed so that you can see me quickly set it up and get it done this way. So what I'm going to show here, now that I have all the shapes in place around the outside circumference, is there's a feature in here that allows you to make the shapes invisible. So once you make the shapes invisible, the value or the importance of that is this invisible area is an area that won't get 3D printed. So these will be spaces in your final object that are not going to require any filament and printing. So you make all the shapes invisible, then you can actually group them together and make it into one total object. So you have to select the entire group of them and then hit a group function, which is just up here. And once that happens, the invisible shapes disappear and you kind of get what the object is going to look like without those spaces filled. So now it's about trying to get the thread on the inside, and there's some useful tools in here to help. So there's a pre-made, kind of like preformed thread tool. So you can pull that out of the menu and put it onto your workspace and then adjust the size of it and the rotation of it depending on which way you want the threads to go, and put in some numbers and try and make it fit into the middle of the orange ring that I had already made. So it takes a little bit of finessing in order to get the right size in there. So my particular concern was getting the thread template big enough so that the threads would go into the ring at the right depth level that I was looking for. So I'm just playing around with the numbers here and trying to get it to fit into the middle. You can also drag the corners and size it that way as well. I just find it easier to put in the numbers. I want to make sure that I keep it perfectly cylindrical and I don't end up making an oval. So I want to make sure that I've got a perfect cylinder as I go in, and it's just a matter of tweaking the sizes of it to make sure that I get it into the right shape that I'm looking for. So the rest of this part of the video is at 10 speed, and you can see how I played around with it to get it to fit inside that ring. So right now I'm just finishing with the thread part of this, and I'm going to group it, and when I group it the shadow disappears and you kind of get a good idea of what the final product is going to look like. After this, I just simply copy another one just in case, and I'm just going to change the colors on them to a gray color and get it ready for printing. So in the next few video sections after this, you're going to see it printing on the 3D printer. So here I am just changing the colors on these. You can pick any color that you want. It doesn't really matter as far as the final printout. The printout depends on what color filament you have in there. So I just wanted to get rid of the orange to see how it looked in this color, and now we're going to move on to the printing. Just a couple quick shots of this 3D printing being done on the printer, and then we'll move on to the actual fitment onto the CRX. So here's the final printed versions. These were done in a draft mode. They weren't necessarily done in the finest quality, and if it fits, I'll reprint in superfine quality, and I'll change the filament to maybe a chrome or a silver color to do that. But I wanted to highlight that these are extremely hard pieces. Like, they're very, very durable, probably harder than the original, so I'm happy with that. You can see inside, I hope, that the thread is in there, so that should work fine. As far as the Honda logo, I was just interested in trying out one of these. I may print another one in silver and see how it goes, but this one is extremely hard as well, which is great, and the quality is not too bad. I can print them in better quality, but we'll see how that goes. As far as the final measurements, so we had a 13.59 millimeter inside hole, which I measured on the CAD. Looking at the ruler here, so we're looking at centimeters. Each one of those little dashes is a millimeter. So you're roughly 13 and a bit millimeters, so it looks pretty good. And then I made the thickness 4 millimeters, and let's just check that out. So yeah, it's pretty much exactly 4 millimeters. Could make it a little bit thicker, but 4 seems to be pretty close to the original. So let's go do a fitting on the CRX and see if it works. All right, let's give this a shot here. There's the choke knob, which I'll put on in a minute. There's the printed part, and hopefully it'll fit on here. So you can see why I put those little notches on it, so it gives me a bit of grip. And you know what? That's what the original one looks like as well. Yeah, so that is in. And it's just a matter of putting this knob back on. It's on here. So that is how that retaining nut is going to work. And I think I'm going to fabricate one out of a more silver color. And based on that fitting, I could probably shrink it down by 0.5 millimeter and it'll work good. So we'll see if I can get that done. Okay, I got pretty close with the orange one. And what I did is, once I tried a fitting of that on the CRX, I wanted to tweak these just a tad smaller, so probably 0.5 millimeter smaller. And one of them I made 5 millimeters thick, opposed to the original 4 millimeters. So I'm just going to do a measurement on them here, and we'll check it out. Reset that. So the inside inside of this is 13.25, which the original measurement that I got off the vehicle was 13.59, and I'm going to take a little bit of measurement for the threads, which will probably make up the difference. So hopefully that will fit on this one. So this was made out of silver filament, same type, which is a PLA filament for a 3D printer. And just for fun, I decided to make this silver logo as well. So let's go out and fit this on the CRX, and we will see how that one works. All right, we're back here at the CRX. Now I'm going to give that a trial fitting and see if it goes on. So this one is a silver colored retaining nut. It's right there, and let's try this one out. So this one's also 5 millimeters thick, which gives a little bit better grip on putting that in. So let's try it out. All right, so that's the final fitting of this one. It fits really well. You can see that it's nice and snug here, and then the choke can come in and out. Tighten that up slightly more. So there you go, you've got a good fit. And the last thing to do is to put on the choke knob, which I'm going to do right now. There we go. The knob is back on, and now you've got a fixed choke. Now it's on to doing all the other crazy stuff I need to do on this car. So here's one area on the car which I do not have the Honda logo, and I'm either going to 3D print one or I'm going to source a new one from somewhere. But in the short term, you know, here is the orange one, and you can kind of see how that would fit on there. Not going to use that, but going to the silver version, you can see that you can get a pretty decent looking emblem on your car for relatively minimal expense and time. So that's another use, and I'm certainly going to put this one on the car for the short term. Hey everyone, thanks for sticking around and watching this video on using the 3D printer to make some small useful parts that are really difficult to source for these old classic type of project cars. So pretty useful. When I was doing this, I noticed some other areas where I could do some 3D printing for some retaining clips for brake lines and other plastic retaining clips that will be useful for this car too. So probably won't make a video on that, but I just wanted to show you that yes, you can use 3D printing to make some pretty cool stuff for hard to source parts, and I was able to get this done for this particular CRX, and saves me a lot of aggravation. So now I have a working choke handle and knob, so it's not going to keep punching into the dash. And you know what, I may tweak it in the future to give me something that I'm more interested in the look and feel, but for now I'm good with what I did. So hopefully you enjoyed this video, you learned something. If you did, hit the like button, I really appreciate it. Maybe subscribe and share with your friends as well. So until the next one, which I hope to get out very, very soon, take care, and we'll catch you shortly.